Okay, transition metals are the elements in the middle of your periodic table. If you look at your periodic table, there is on the key a section that tells you oxidation states. Okay, so if you're looking at your periodic table, look at where it says oxidation states. Okay? For metals, and it's important that you understand that, for metals, we are talking about the charges that are available for metals. So if you go to iron, which is number 26 now, you should see that iron has a 2, a 3, and a 6 for oxidation states. You see that? Yeah. Okay.
When it's bold, it's the most stable.
Right. The bolded one tells you that's the one that's most stable, which is the one that's most often combined in ionic compounds. But if iron has 3 charges, +2, +3, or +6, the first question that you should be asking is, how do we know which one to use? Another question that you might be asking is, does it matter which one is used? And if these two questions are in the affirmative, how do we know? Maybe we figure that out. Or does it matter? Yes, it does. Then the next question is, how do we know which metals have multiple charges? Okay, so we just talked about knowing that the oxidation numbers or oxidation states tell us that metals that have multiple charges. It does matter which one is used, so we need a method to tell you how we know which one is used. So if you come down here, iron with this Roman numeral is telling you some information. What is this Roman numeral telling you?
There's 2 iron, no 2 chloride.
What is the Roman numeral? Well, go back up here. We've got a +2, a +3, or a +6.
Oh, it is charge.
The Roman numeral tells you the charge for that iron. So when you write a chemical name with an element that has multiple charges, you need to include Roman numerals. Now, I don't know what your feelings of Roman numerals are, but don't panic, because the highest number Roman numeral that you will need to know is 4. So 1 is 1 line,
IB.
2 is 2 lines, 3 is 3 lines, and 4 is IB. Okay, so those are the most complicated, or this is the most complicated Roman numeral that you need to know. So if we know that the Roman numeral is telling us that this is Fe plus 2, then we know what the formula is going to be, because chlorine has only 1 charge. We know that chlorine from the periodic table is Cl minus 1 to give us FeCl2, which is what we see over here in the formula. But what in the formula tells us what the charge for iron is? Is there any information in this formula like we saw over here in the Roman numeral?
The 2.
The 2 for the chlorine, right? If we reverse what we did before and sort of uncrisscross, we know that chlorine has only 1 charge. So iron has to be a +2 because ionic compounds have to cancel each other out.